Good morning, people online.
Good morning.
So, for example, what I was telling you is that on this node there was a demand, yes. So here we passed here to add that demand in this corner. So you can assign many demand on a node. This is the only one which should be here. You can add others at the same node of different categories. The same node, different categories. Yes? You get this? For example, if let's imagine that at this level, yes, there is population. At this, for example, at this this way, along this way, there is a population, there is an industry, there is a hotel, there is many categories of populations. Yes, then you can come here, and then instead of creating not for population, not for industry, not for hotels, you come here on this node, you just go on demand, you just put here population. We will see also to do patterns. We will see. We do population, we do prisons, we do industries, yes, or on that node, and then you close. It will be assigned. Here they will tell you that you collected three demands, yes, and then you learn. So I was telling you now, if you find that this one you don't need anymore at this level, yes, you just delete it here. Yes, as you can even add the other one. It was easy. We are good. So hello, people from online people.
It's not okay.
Online people, are you there?
Yes.
You are there? Oh, good.
Yes.
We are about to start.
Yes.
Have you now know how to share your screen?
Yes. I've already know.
You already know?
Yes.
Can you share it with us? What you already did?
Just wait a minute.
Yes, you have it.
Unmute your mic. Too late.
Yes, can you can share your screen?
We have already shared. We have already shared.
Okay, good. You did it at the pump.
At the pump? Yesterday
yes.
We don't get you at the pump. We did it yesterday at the evening. Was not even here.
Can you learn the model at least?
Yes, we can learn.
Validate, yes.
Compute.
Good. You are doing a great job there.
Thank you.
So then I want you to know, you know how to add demand?
Yes, we know, but not yet.
Not yet.
but we can add. But the big problem for us, how to size the pump. We didn't
You just add demand. You just add demand.
Okay.
I will be right, or you can just wait. How I'm going to proceed, because you are still far.
Okay, you can proceed during when you take a breakfast. I think we continue. You can proceed.
Okay, you just when you find my mic mute, you proceed with adding demand, because I will mute many times. You can just proceed adding demand.
Okay.
And then during the break, I want you to finalize this one, and then show you how to with the pump. Yes.
Okay.
Yes.
It's okay.
It seems that there is somewhere that there is a demand. What about that pipe which is getting out directly from the tank? I see
from
flow.
The tank?
Yes, that one. No, the other one.
This one?
Yes, there is a flow in that one. Yes.
There's no flow. This is type P3, not flow.
Must be a flow there. Okay, you just add demand.
Okay.
And then continue following. You are doing a great job. You are doing a great job.
Okay.
This is good.
Okay.
So stop sharing.
Okay.
Yes. So we are going to have our third day. We are going to start by see how to do scenarios and alternatives. We will create some scenarios and alternatives. We will start to compare those scenarios and alternatives, and we will see the advantages of advanced feature in WaterGEMS, pressure zone management, fire flow analysis, and then we will get. I don't want today to go through GIS. Yes, I just want you today, at least in this afternoon session, to have a big water supply systems, to size it together all, and then do optimization. Try to do optimization, try to design, to see all of those stuff of today. Yes, we already had some design criteria. We already have some. Yes, so economic consideration is that optimization that you are doing, how to position your pump, how to all of those stuff. Yes, so I want today in the evening session and tomorrow morning to have a big network that we will be working on it. Yes, we all know how to put everything now. Yes, so it's better if we do exercise just immediately today, so that we not forget what we had yesterday. So during this morning session, we will see those scenario things. We will see how to do pressure, and we will see also how to do report, because yesterday we didn't see how to produce report, how to produce a pipe report, how to produce a junction report, pressure report, all of those reports. Yes, we are going to try to cover this session in the morning, and then tomorrow we will see now we will start the GIS. Yes, to see how all those things we saw can be integrated then with GIS. Yes, okay. Online people, are you there? Because we are going to start. Hello? We are going to start. Hope we are all having this small network that we designed from yesterday. Yes?
Yes.
Our network is validating. Yes? Yes, please?
Yes.
Our network is running. Yes, please? I want to know if it's yes. Yes. Then
Yes.
how to create scenarios. So we are going now to see the things of scenarios. So to me, there is in one way that you may be working on a network, but you want to see if, for example, the demand of this area is increasing. What will happen? Yes. What if the pipe, for example, I have this pipe here.
Share your screen. Sorry. Okay, now you can see.
You're seeing it, man?
Okay. We have already seen. Yes.
So you may see what if the demand here is increased. You may need it. What if the demand here or the network here is extended? You may need different scenarios. So instead of creating two models, there is a way just of doing some like doing two models, but in one model. So you just change some parameters, you run the model, and you see how the system will act. Then you continue. For example, let's take first of all how to create scenarios. So you just have to create just alternatives. Come here. The first things you do is to create alternatives. So there is many ways that you can do alternatives. You can do physical, you can do demand, you can do initial settings also, operations, edge, traces. All those things are possible to do alternatives. But for us, in this session, we are going to be based only on demand and on physical alternatives. Demand alternatives and physical alternatives. In each one, we just have the base one that we are using. The base alternative, that is the one that we are using right now. To mean, we have the base physical and the base demand is the one that we start with. Yes? So then, when you want to create another one, you just right click on it. Let's start on physical. You just right click on it, and then you do new and create a child alternative. It means it's like the first one, but which will be having like the smallest changes in it. Yes. So, but before, let's see what is in the physical one. By clicking on it, double click on it, please. When you double click on it, you will immediately see a kind of reflex table. Yes. And most of the time, they are giving you all the properties that you had for your pump, for your pipes, for physical. So you will see we have all our pipes here. Yes. The way we design it. Yes. The way we design it. So then, when you create a child alternative, they will give you another one. Yes. Let's call it physical alternative one. Yes. By double click on it, you will again see the same things that you already designed it, but with a possibility to change some characteristics. Yes. For example, you may need, for example, to let's see, to say what if the transmission pipes, my transmission pipes, I make them 75. Yes. So you go to check on your transmission pipes. My transmission pipe was this one, P1, P12, this one, yes. and this one, I think, yes? So what if I make them 75? Internal diameter is which one? 65.6. Yes? And this one also? I did. 65.6. And this one? The same, 7.6. Yes? So I'm saying that this one is changed. Yes? Yes? So for this child scenario, I already changed those pipes. Yes? So I cross this one. So you will see, for base scenario, they are still the same. Yes? But for child scenario, child alternative, they have been changed. Yes? So then, let's start with physical. Then, after, I will now create a scenario. Yes? How to create that scenario then? I will come here to scenario, click here. Every time, you will find a base scenario, the one that you are working on. Yes? To me, it's like a model of our model, the one that we are working on. Then you create a child scenario. What? Okay, then we create a child one. After creating that child one, you may call it, okay, let's say scenario one, physical. Yes, you just create on it. There will be these icons coming. In this one, you will need now to see the physical. You know what? You have those alternatives. All of those alternatives that we have in that icons that we may change. Yes. So from here also we will have them. All of them here. So then we change the physical one. So, yes. So you go on it. You just get the physical alternative one. Yes, the one that you had. You remember in that alternative. Then you click on it. So you can cross this. Now, you see these sticks can be here. When you do this, it means you are going to run this one. When you do this, it means you are going to run this one. Yes? So then you can run the first. This is running the same as we used to run. Yes? You can check the pipe here. The velocity is still that one. The diameter, this one. Yes. The velocity is still that the one, 1.2. Yes. And then you can even pick this one and land this one. Yes. So you get the pipe have changed. Yes. The velocity as well have been changed. You get the difference. So from there you can create many scenarios, many options. What if I change this pipe to this one? What if I change, I increase? There is also a way of adding many pipes. Add many pipes, you put them in some scenarios, in others there is, you create them, you run one by one and see what the difference. Yes? Is it okay? No.
Can you repeat how you go from base to scenario one physical?
The way
you reach that scenario one physical.
Scenario one physical.
Yeah, I know that you click there at scenario. You get this.
So by clicking, let me, for example, delete this one. Yes. So by clicking on scenario, immediately I got this one.
Base.
This is the base one.
Base. And you can
So let me first explain this one. I will also turn to others. So then from here, I just right click on it and create a child one. Right click on it and create a child one. The one which will be based on the first one. Yes? Hello? Let's see now how for demand. Yes? Let's do for demand. For demand also, you have to start from alternatives. So you create an alternative for demand. Yes? You know here you had one for demand. We have a base demand, the one that we were using. Yes? You create a new alternative, a child alternative. Yes? And then after creating a child alternative, you go to change what is the demand, what you want to change. For example, in this one, you will have all the junction that you want. Yes? So you may see the demand that you have at each one. Yes? For this one, you have this one. For this one, there is no demand. Yes? For this one, there is no demand. For this one, we remember that yesterday, all demand we make it 0.17. Yes? So now you may choose the one you want to change. For example, you may say, in my child scenario, my child alternative, I want, for example, this one. I know this one is the last one. Yes? I want it to add, for example, a hotel there or an industry there. And in my industry, we'll be having like 0.2. We need 0.2 liter per second. Yes? So we had a plan that maybe in 5 years, in this area, there will be an industry, a factory. So I just see when that factory will be constructed there, what will happen to my network. Yes? I just create a child alternative. I just add this demand here. Yes? And then I close. So you will see from my base demand, you will not find that one. Oh, you will not find that one. Yes? Is it there? It's not there. Yes. But for my child, you're going to find it. So then you return again to a scenario. Yes? You create a child scenario again. Call it demand. Yes? And then I got assign demand, assign that alternative to this one I did. Yes? And then run my model. I want to run this one. So you see that there will be a problem. Yes? It's showing me that there is some negative pressure. Yes? So my negative pressure is where you all know how to look where the negative pressure is. You go to junction, table of junction. Change the unity. The unity is being changed. So then I can sort it by sending to see where there is negative. I have only this negative pressure, yes? And I'm asking myself, where is it? It is here, at that node. To mean, after 5 years, when that factory will be constructed, I need to change because the water will not reach this place. Yes, you get. So try yourself also to add, for example, 0.5 on this node, and let me know what will happen. You already did? You want? I come? People from online, are you there? Are you there?
Yes. Yes. But we don't see your screen.
I was asking you many times, you wasn't there.
Yes. We replied, but you didn't hear us.
So then, where are you? You already put the tank and everything?
Yes.
Okay, I want you to follow at this level.
Okay.
And the afternoon I will be with you only, because others will be having an exercise.
Sawa.
Sawa?
Sawa.
Oh, okay. You follow. Just stay there, follow.
Okay.
So then, press the main option, and then you activate using the entire network. Yes. Here they are asking you patterns. Patterns were not yet arriving at that level. Huh? Sorry? Okay, you left. You are left. So where do you start? The scope. The scope is here. Before.
Not before. Explanation after explaining the scope.
Okay. After selecting the scope, they are taking you on the patterns, the main patterns. Most of the time when we are adding demand, you were seeing that it is fixed. Fixed. It was written fixed. Yes. You remember? Those are patterns. So there is where you mention the categories. So we will create patterns after this one. So it's where you create categories. So here we still have a fixed one. So then they ask you the operation that you want to do. Yes? The operation that you want to do. Either add, so take those demand, add for example 5. Take those demand, add for example 10. You will divide, multiply, set, and subtract. Yes? So you do whatever you want. So for the factor, most of the time they're asking you to multiply. Yes? So here, let's take our demand and multiply all by 2. The common factor that they are putting is 2.5. But I know if I multiply 2.5 on 0.17, maybe you will not see it correctly. But by multiply by 2, we know all demand will be 3.4. Yes? Let's multiply by 2. You do okay? Yes? You cross, and then you run again your network. How is it? Pressure below. Yes? The pressure below. Try to check on one of the junction. The demand. Has it multiplied by 2? Yes. Yes or no?
Yes.
Yes. You see, it's calculated. It's all demand are being multiplied by 2. So if you want, you can even just create a selection set to see. Just a selection set. Let's create a selection set. We all know how to do. Yes. of node. Let's take the same one to see. Take this one. Take this one also and this one. We create a selection set. We call it what? There are some who doesn't remember to create a selection set. No. We call it what? The name, please. Tabs. Free tabs. Okay, free tabs. Yes. We do okay. Yes. Immediately we will find that one in our selection set. You remember where to get it? Here. So it's already there. Yes. You can even check on those free tabs by double click on that. Yes. So then I want you to go in demand adjustment and you multiply that free tabs set by 2.5. Yes. You go to demand adjustment and add a factor of 2.5 to those free nodes that we created. Yes. There are some who still want to see them. They are those ones. Then, after seeing how to add factors, we are going to see patterns. All before that, there is another thing that I want.
Share your screen. We can see.
Okay. No, they're about to kill me. So let's see patterns. So patterns is the way of putting categories. As you said, when you are giving a demand to a node, it's better when you specify if this is domestic, if it is industry, if it is livestock, if it is water. All of those categories must be specified so that someone who will see it will know this is a domestic. It will be easy for him to differentiate. So the way of doing that, you come here.
We did not hear you, sir.
I'm not mute.
Okay, I don't know why.
You are here. You are seeing my cursor.
Yes, your cursor we are seeing it.
So we are together.
Okay, we are together.
Yes, we are together.
Yes.
So then you come here. There is an icon here. It calls patterns. You have it all. Yes, you click on it. There will be an icon like this one. So then from here, you can find a patterns of reservoir, patterns of valves, patterns of isolation valves, patterns of hydrant. You can create one here on hydrant, for example. You call it domestic, for example, domestic. The way we are using to create. Yes. You may create, for example, for industry also. What else? Commercial, yes. What else? Administrative, yes. At least now I have many. What a difference with administrative and institution? They are the same. Well, those are enough. So then you remember why we are used to give demand, yes? So then by clicking then on demand, you will immediately find that instead of having only fixed here, you will be having other things that you are adding, yes? It's immediately appear here. Sorry? Patterns, the way we used to add demand. Go on notes. Go on notes. You do demand collection. Where is it? Here, demand collections. You just click on it. Instead of here, let it fix it. Now we are going to choose. Is it commercial? Is it domestic? Is it industry? Is it what? Yes? So then, let's call it domestic. So when you add another one, for example, like the one we are using 0.2, yes? You choose also, is it for industry? Yes? Continue. If at that node there is many different categories of demand, you may also add them, yes? So then, from here also in demand adjustment, you will find that at this level, instead of on the demand patterns, you will be finding all of those stuff that you are needed. Yes? So you may find that if you find that you need to, the demand that you are taking is for industry, you take those industry, you multiply and you get the difference. Yes? Yes, please? Okay. I want your model to run. This will be seen in the exercises. The word that we did will be seen in the exercises. Yes? So then, I want you to delete this one so that your model will run as this one. Did I change somewhere else? Huh? Still here, this one. Oh, it is stuck here. Oh, I'm in scenario 2. I want the best one. Thank you. Okay. Then someone asked me, I'm seeing this like a plan view. Yes? Yes? So what if I want a profile, for example, for this type, for this tank to this area? Yes? Because most of you are using profiles also. So let's see how to sketch those profiles. Yes? Okay. In view, you will find where it is written profile. Those profiles can be used even in the report. So you click on it. An icon will come like this one. Yes? You get all. Every time, remember, you have to create. Yes? Create one. Profile one. With this icon. Yes? You can name it. From tank to
Stop it.
up 8. Yes? Then you have to select that place. Yes? Select from the drawing. When you are selecting, you have to select where your profile have to come to where it have to stop. Yes? So then I select from the tank. Yes? To 0.8. Yes? Then I do OK. They will show immediately all of the points that I passed through. Yes? And then here, open the profile. My profile will be like this one. What? If you want that one from AutoCAD, it's difficult, but it have almost the important information that you may need, because it's have elevation. Yes. It's have elevation. Yes.
Yes.
It's have distance, and the hydraulic pressure.
But it has no material, like pipe size.
Yes, the material cannot find it here, but
Pipe size.
as you will see, as I told you, there is many information that you will not see. You may need also the slope, yes, the flow, but you can see them in your pipes because you already have attribute tables. I will let me tell you. I will. You see, just I did what I did. Yes, it's just to show a profile of this line. Yes, in the report after we will also show the pipeline. Yes, while you are doing the report, you can show the pipeline, a list of pipeline which is from here to here. Yes, velocity, everything, and then after you show also the profile of that area. Yes, it can also be done. Let's do another profile, for example. Yes, from here, everyone can do it from here to here. I want to see them in your machine. From the tank here to here.
It's asking you to have.
You have it? Okay, I'm coming. But there is a negative pressure in your system.
Yeah.
Mm-hmm. Why? You see, it immediately says if you have a negative pressure in your system, where you are passing your profile to immediately be seen.
Demand is on what? New
Okay. So then we are going to on report. We already says everything is okay. So then we are going to produce some reports.
The first report which is being needed is a pipe report, yes? A table of pipe reports. Do you produce that also? With Excel?
Yes.
With Excel you produce it? Pipe report.
Table pipe report.
Yes. Or you do those Excel and it's done. It's already there. Okay, here also, the pipe report is not something big. You just have to open the reflex table. Reflex table of pipe, yes. So then, what you have to do is to think in my report, what the important things that I want to show. Yes? What the important things that we might show in our report. If we want to include a table of pipe report in our big report, what the important information that. Starting point and the end point, yes. Length, thank you. Diameter. Material. Flow. Velocity. As in coefficient, no. And pressures. Starting pressure and the stopping pressures. Most of the time they are those one. So the first things to do is just to have a label. Yes. Starting from this point to that point. Yes. Which pipe the material. Yes. If the material is this one, you have the internal diameter of this one. Yes. The flow, the velocity, the length. The length most of the time it comes after. Yes. And then you can add pressure start and pressure stop to see the pressure at those levels. Yes. And the length. As in William, no, you can remove it. head loss also if you need, but it's not necessary. Yes. So after having your table, your reflex table like this one, make sure that you include all of the things that you want to put in. Yes. Then you can come here, you just select all. Come here, you copy with header. Yes, copy with headers, then go to Excel. Oh. So, Excel, is it open? Yes? Then from there you can even copy. Paste. It goes there. Yes? And from here you can arrange your pipe, your table. Yes? Arrange that as the way you want. Yes? But still you have pipe. This pipe is this one. You have this lamps. You have everything that you may need. Yes? And after, you can even sort those one. Instead of having 14 and 14 here and 14 here, yes, you just do just a summary to allow your manager to see we have a pipe of 14, which is having this length. Sorry. Which is having a certain length. So you combine all similar pipes of all similar pipes together to have just a small summary that can be shared with big managers. Yes, and also it will help you to do also the BOQ. Yes, because you will not put this in BOQ. You just do another summary for those pipes, small pipes, make them together and you produce a BOQ. So then from there also someone asked me why not seeing some information of here. For example, when you are doing report, you can just create select. You can select this path. Yes. And after you open, you remember the way of opening what is only selected. Yes. And then produce the only a report of that portion of. Yes. You get. Then you can do both. Also that for the tank report, because you also have the tanks. Unfortunately, we have one here. Yes, please. You can also do a report from the tank. You just do the same scenario. Yes, you put the the elevation. If you may need the elevation, you put the labels, you put the X, the Y, and the Z. Yes, most of those are the most important properties that might have the tank. Yes. So also for the junction, it's the same. Yes. Yes, please. Then this was a part of the report. Most of those reports are coming either with the graph or either with those tables. Yes. So then I want to show you if, for example, one of us is using GIS. Yes. And we want to export the pipes as shapefiles. Yes. You just come to attribute table again. Yes. Then you come here. Export files. Yes. Here they are asking if you want to export them as shapefile, export them as text, export them as CSV. Yes. No, those are format of Excel. Yes. So then you can choose shapefile. In shapefile, you choose where to save the things. You name it day 2, day 3. Right? Remember, there also you have to specify. You know, shapefile. You cannot combine the pipes or lines with dots. You have to create shapefile of pipeline. You have to create shapefile of tanks, shapefile of reservoir, shapefile of junction, or part, not together. Yes. So then you do okay. Most of the time they will ask you what will be in your attribute table. Yes. So those in yellow are the one we have in our reflex table. But most of the time, the attribute table, you know, for those who are using GIS, they have many criteria. There are some characters which doesn't go in, and there are big characters. For example, the title can have characters which is more than 10 or 8, things like this. So the model immediately gives you the names of what they can put in attribute table. Yes. So you check if it's good for you. The diameter is still diameter, flow is still flow, gradient is still. You check. Yes. You see pressure. It's only pressure P. Yes. So it will help you to know when you are reaching the attribute table. So you do okay. It's run, and then you go where you save your shapefile. Problem is that I don't remember where I saved. Anyone have so? Huh? Where? Let me see. Don't just remember where I saved. Morogoro shapefile, yes. Okay. So you see that my shapefile are there. So then you remember that shapefiles have 4 files. Yes. So to me, the shapefile which is being produced here is not projected. I have to project them. Yes. By projecting them, the 4 file will be created.
The 4 files.
Yes.
One projection.
No, we just did the for the pipes. Here we have a shapefile of pipes only. Yes. So you will create also a shapefile of junction. You will create also a shapefile of tanks. We will create also a shapefile of reservoir. But those shapefile, a shapefile of GIS must have four files. Now the WaterCAD is producing 3. They are missing one for projection. You have to project your profile so that the 4th one comes. How do you project? This is another course of GIS. Yesterday we sent introduction on it and how to be integrated on it. And with GIS, this can be opened in GIS. But that one will not be projected. No, they fall at the exact location, but without a projection. You have to project. You get it? Because it have X and Y, whatever. But it doesn't, the projection is not yet defined. Yes, it will fall at the exact location. Good. Yes. So you see, you open a shapefile. Yes? That shapefile will fall at the same location. But when you check the projection of it, you will not get it. You will have to project to define a projection. Okay? So then, that was the case of WaterCAD, of GIS. Yes? There is also a way for those who are using AutoCAD. Yes? Or Civil 3D. Yes? There is a way also of exporting the network, the whole network, into DXF. Yes? So when you export this into DXF, it creates the whole system. Yes, we're getting. It creates the whole system. So from here, we call it how? No, there it gives everything. Day 3. Yes. Guys, I'm doing quickly this stuff. We'll continue having it. It's like the first day there was things that I was doing quickly, and the next day we continue having it. Yes. To export the card, I go to File, Export here. Yes. File, Export. DXF, yes. So there is there is many ways of exporting. You can export as an EPANET. Those who are using EPANET, maybe one of your organization or one of your consulting firm will tell you, you know what, we don't use WaterCAD or WaterGEMS. Yes, you give us an EPANET file. Yes, you just, after finalizing everything, just export it into EPANET and you give them. Yes. The problem with EPANET, when you import it, the pipe does not come. When you import the file of EPANET into WaterGEMS, those properties are lost. There are some properties which are lost. The line are still there, but the properties, you have to start again. This one, it goes. Yes, it goes. Then you do the DXF. Yes. The name is Day 3. Day 3 what? Card. Yes. Then I said it where? Okay, to shapefile. Here also they are asking you if you want those pipes to be laid and the size. You do okay.
Yeah.
Okay. So So you get the deck safe here. Are there someone who has a WaterCAD or?
But that one is for 5 points.
No, it's for all.
Oh. Can you go back to
The entire model.
Can you go back to water? That's how you the spot.
Yes, I export.
You export.
Yes, I got to 5 and export. Hapo sawa? Okay, tunaendelea sasa. By side. Yes. It was let me see. Okay, open it.
Anasema okay.
Thereby says yes. I checked this one.
You check those.
Yes, because we don't have laterals in our. Yes. So then, you see that we have subiri. Subiri. Subiri na Joe. People for online people, are you there?
Yes.
Online people.
Hello.
You are following?
Yes, we are following.
Okay. Good. Now, to me, when after doing your survey, yes, there is someone who can just start by sketching those lines, yes, because you know where his point is. So because you know where his root is, you can say, so me, I'm just going to open my AutoCAD, yes, and instead of going in the WaterCAD, sketching those lines, I'm going to sketch them directly in AutoCAD, yes, and then import everything in WaterGEMS and start simulating, yes. It's also happened. So you just take your coordinate. Yes. After coming from the field, you just import them into AutoCAD. Yes. And then after importing it into AutoCAD, you just draw those lines. Yes. Yes. And after drawing those lines, there is others who immediately start doing profile. Yes. You just after coming from the site, you just produce profile. After finishing profile, you will be having those lines also. Yes. You can use them. Others can just draw them as they want, and then you will be having a card like the one we are seeing there. Yes. Okay, then how to take a card and put it into WaterGEMS. You can just create a new file. I want you to create a new file. Just from here. A new window, yes. People online, are you there? Are you there?
Yes.
Hello?
Hello.
Okay, we are together.
Yes, we are together. We are together.
Yes, tupo pamoja.
Ndio.
So then we are here, all have this. So to me, there was many pipes because AutoCAD, it was sketching small pipes. That's why you are seeing many pipes here. Yes, it's showing us what was there. So you have your reservoir. Yes, you have your tank. Yes, what is not it's those alloy which are not needed. Those flow arrows, we don't need them. Yes.
Yeah.
Yes. Okay. And then you have field cycle. Field cycle, it may become junctions. Yes. So then you proceed. You can preview this one. Yes. So then you do next. They will ask you if you want to teach which unity. Yes. And then here there is establish a connectivity using spatial data. Here it means there may be a pipe and a node. The node is here, and the pipe is somehow here. It's not connected here. So they are asking you if in a distance of 1 meter apart, the system can connect this pipe and this node. Yes? You take that one, a very good.
So you can add even the right, maybe you put the tolerance to 5 meters.
Start, yes. Yeah, 5 meters. But it's not good to put a length which is very high, because when it's become very high, it starts confusing. Because there is, in some models, you will find that pipes are almost passing here and there, and it may catch another pipe which is not connected to that. Yes. So the others are the same. Reaching at this level, they're now asking you again the same questions. Yes. So let's start on the field one. The field one, they are junction. Yes. So you specify the key label. Yes. The key label most of the time is label. Key field is label. So because for the CAD, our CAD, we doesn't have especially those X, Y, and Z. You specify that it will be automatically. Take the location that it has and put them automatically. Yes? So this was for the field here. Yes? Yes. Then you go on pipe also. This should be pipes, which should be labeled. This? Yes? The level. With okay, thank you. We have to see the elevation also. The elevation, yes, thank you. I forget. We are good. Then we go on pipe. Most of them are pipe. There is no other way. The key field is label, and for this one you don't need to specify if it's for starting or it's for ending. Just get the direction when you land. Yes. For all pipe it must be the same. For this, but the label, how to specify the key field? It should be the label. The pipe does have a elevation. Someone asked about elevation. I'm asking if the pipe have elevation. No, yes. There is no pipe will have elevation on the junctions, yes. Don't forget to specify the key field. Exactly. At the pump, you specify that this is a pump. Yes. You want the key field to be the label. X and Y will be done automatically. But for the pump, we have to specify the elevation. Yes. For the reservoir also, you will need to specify the elevation. Yes. For the tank also. Pump.
For pump, there is no need to change downstream edge.
There's no need.
There is no need.
No need.
Don't have it.
That's interesting.
Mr. Ashur,
Yes.
for tank, I remember we have those elevations, different elevations. Yes, initial.
That was because it was specified in Excel. Now
For here,
we don't have
so we just select the
one elevation. Then you can do next.
Hiyo ambayo tumefanya kazi.
Aha. You get the result? There is 18 junction created. They are the same as before. Yes. And different pipes was created. One pump was created, one reservoir was created, one selection set was created, and one tank was selected. Yes. Are together? From here I can cross. I'll ask you if you want the drawing to be synchronized. And it's here. You get? You see? Huh? Our reservoirs at the same location. Our tank at the same location. Our pump at the same location. Everything at the same location. Yes? I may ask yourself what will be remaining. Are we all here? Good. So I see you added the. Have you added the? Not yet the pump.
Yes, the pump was a problem
Not yet.
for
You
me.
didn't yet.
I did
Can you run it?
yesterday.
Okay. Your network is running. The demand I see you put it well. So I want you to see how to put the tank, the tank, the pump.
How?
So stop sharing. I'm going to show you. We proceed after me.
Can I stop my sharing?
Yes.
Okay. Share your screen, sir.
It's already shared.
But I can see. Okay.
Get
Now
it?
I see.
Now
Yes,
you are seeing.
I see it.
So let me delete this one
Yes.
to be at your.
Okay.
I delete this. So then I add that pipe. Okay.
Mm-hmm.
So I think your network is here now. I validate
Okay,
to see.
sir.
I validate also. Okay, then we are going to add the pump. So you remember yesterday we calculated the characteristic of the pump, yes?
Here's the characteristic on the pump, yes.
So
But how to use that sheet?
Sorry?
I remember we calculated the characteristic of pump, but how to use that sheet, speed sheet, I don't get it. You can continue, but you can continue.
Okay. Then we're going to put the pump. The pump, you take the pump,
Okay.
yes? And then it's recommended to put just right the reservoir where you want to sunk water. So then I put my pump. They're asking me if I want to split this into, no, put on reservoir. They ask me if I want to split the pipe into two. Yes, I do, yes. So then my pump is there. Yes. Yes. So then after putting my pump, I have to define it. Yes.
Okay.
I go to property of it. Then I get where there is pump definition. Pump definition is here. Yes.
Okay.
I go on it because you see there is no pump definition in it. And sometimes they will ask me if I want to define the pump. Yes. They are telling you edit pump definition only. Yes. You click there. It will be this icon.
Okay.
Yes.
Yes.
You are here.
Yes.
Okay, then you create a new pump definition here. Call it what? Let's call it what?
Pump definition.
Call it pump definition only.
Let's pump one, okay. Let's call it pump one, yeah.
Okay, let's call it pump one. Thank you. Then we have to set the types of the pump definition that you want. We are designing design point, 1 point. I take this one. So it will help us just to use Q and head.
Okay.
Yes?
Yes.
Okay. Then yesterday we calculated the pump using our knowledge of engineering. We get that the pump we are going to use have a Q of 3.4 liter per second.
3.4, sir.
And then the head was 40.
Mm.
Yes?
Yes.
If you feel like I can help you again in pump calculations, maybe later, yes? But
Okay.
let's have this one. You will immediately have a pump curve. Yes, you can set your efficiency and allow the pump to work on best efficiency point. Yes.
Okay.
Efficiency is better to make it at least 75 is the minimum allowable.
Yeah.
Okay.
Okay.
Then at this stage you can cross this.
Okay.
After then you go to the property of the pump. Then yes. And then you go to pump definition. You give that pump a definition of pump 1. To mean if you have many pumps, you can create many definitions, and each pump you give it its own definition. Yes. Okay. Then you cross and you validate your network. If there is no problem, you learn. You run. Are you there?
Yes.
It's run.
Let me do. I was listening to you.
Is it
Now
running?
let me done.
Hello.
Hello. I have shared my screen.
Yes. Yes, I'm seeing your screen.
Yes, and I have a challenge. Yeah? My water flow from the tank to reservoir. You see, I have a problem with this friend.
Yes. Hey, you do your assignment. Do your assignment. Yes, please. I'm getting you. You have an issue here.
Yes, I have a problem. See my my layout.
Yes, I'm saying. Yes.
You see? Yes, I have a problem. The water flow vice versa.
Your tank is pumping from tank to the reservoir. While it should pump from reservoir to the tank. Yes?
Yes.
So to mean, you have to reverse your tank. You double click on it.
The tank?
No, the pump. Right click on
the pump.
Right click on it.
Yes. I've already.
Right click.
Okay, right click, yeah.
Then reverse.
Reverse. Let's see.
Up.
Okay, let's see. I've already clicked.
Yes.
And then?
Run it again.
Yes.
Now it's okay.
Want me to repeat again? It's okay now.
Sorry? Is now okay, right?
Yes. It's okay.
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 That's good. Then,
yes.
What else you want to have? Because you already put the pump. Do you follow when we were putting the factors?
To put the factors, I want you to repeat it, the place where you do adjustment of demand. I don't get you. Where, if I wanted to do adjustment of demand.
Demand adjustment.
Yes.
Yes, demand adjustment. Then go on option.
Where it is option. Is this one?
Yes. Base demand calculation. Let me share my screen to proceed.
Okay.
quickly.
Okay.
So, demand adjustment, you come on option, yes.
Share my screen, sir.
Base calculation.
You go.
Sorry.
You can start.
Then you go to. You have to demand adjustment to activate it first. And then after activate it, you come here. Active demand adjustment. Then click on this one. And then here there is a scope. The scope is one of the selections that you already chose. One of them. You remember by creation of the model, there is one selection set which is being created. So we created another one for free tabs. And the last one we created Monday, this one for service line. Do you remember them? And here you can choose the entire. Here it will require you to check on the patterns, if it's commercial, if it's domestic, if it is industry, and then you specify if you want to multiply, if you want to add, if you want to subtract, yes, and then you add the value, yes.
Okay.
Let, for example, multiply by 2, our whole demand, our entire demand. Let's multiply it by 2. You do okay. Yes. And then you cross this one. You run your model to see what have been changed. All of your demand, yes, all of your demand will be multiplied by 2. You see here? Why the base demand was 0.17, yes?
Yes.
Multiply it by 2, it become 0.33.
Okay, so.
You get it?
Yes, I get it. Okay.
You get it, please?
Yes, I get it.
Okay.
I have already seen.
So,
it's okay, sir.
It's okay? So then,
it's okay.
You get another issue?
My issue I have, the first issue to calculate this is the characteristic of the pump. I didn't get you yesterday. Can you repeat for me just a few minutes to calculate the heading?
I repeat for you what?
To calculate the head of the pump.
How I calculated the head of the pump?
Yes, like you do yesterday.
Do you get the Excel? Do you get the Excel that I shared on WhatsApp yesterday?
I mean, you didn't send to me.
I shared it on WhatsApp group.
WhatsApp group. Let me see. Okay, I will see it. Let me see.
Have you get it?
Let me open the phone.
So your Excel is looking like this?
Yes.
Okay, then what you have to do then to calculate the characteristics, yes? You have to know the flow.
Yes,
the flow which is required. You know how to check on the flow which is required?
Yes.
How?
You just on the demand, which we supply to our system. It was 1.7, and
Yes.
then we just what is the hours I'm going to pump.
Okay. So our network is having a demand of 1.7. You can see it just right here, even. You can see it here. The flow demanded 1.7. This flow is for 24 hours.
For 24 hours.
Because we want our pump to work on 12 hours, we have to multiply it by 2, and we get 3.4. Yes.
Yes.
So our Q will be 3.4.
Sawa.
3.4. Okay.
Okay.
So the pipe that we are going to use is the pipe of 63. Yes.
Okay.
It has the internal diameters of 55.
Yes.
You still remember?
Yes.
So then we have to find the length of our transmission line. Yes.
Yes.
The length of our transmission line is from here to here. So in order to have those pipes, let's remember how to trace the shortest path
Okay.
from reservoir to the tank.
Okay.
This is my transmission line. Yes.
Yes.
I open only those pipes. So then I get the length. The length is here. I can get it on the statistics. I get 402.
Sawa.
Yes.
Yes.
So to mean the length of my transmission line is 402. I put it here, the length.
Okay.
402. Then I'm using an HDP pipe which has an ion coefficient of 140. You remember?
Yes, I remember it.
Yes. Then I get my head loss. This is the head loss.
Okay.
Yes.
Yes.
So then I have to get the ground level where water will coming from and the delivery level where water is going to. Yes.
Okay. Yes.
So my ground level is this, the level of my reservoir.
Okay.
I copy this. Or it's 1078. Yes. 79.
Okay. Yes, 79.
I go there. 10.
Yes.
79. Yes.
Yes.
I also go to delivery point, which is this one. This is 1088.
Yes.
Yes. I put it here. 1088. Yes.
Yes.
And immediately I have to put my flow also here. Yes, design flow, which is
44.
Yes.
Yes.
And immediately my calculated head will be this one. And you are seeing that I'm getting 31. Yes.
Oh, yes, 31.
As we cannot get the pump for 31, we just adjust it to 40 by putting also a safety factor.
Okay.
The estimated one will be 40. Yes.
Okay.
That's where those characteristics comes from. We have our Q,
Okay.
then we got the head of our tank.
Thank you. I understand.
You understand?
Yes, but I have another question. Can I share my screen? The setting with the
Yes, you
tank.
can share your screen.
Yes, let me share my screen and ask you some questions.
What? You are tired? So you guys, I want you to be on top. There is another things that I want to show you. Time is running. Don't go home.
It's running, but this is very tough for you.
No.
Very tough.
Have you shared your screen, please?
I already shared it. I already shared it.
Show me.
My question.
Yes, I'll see it.
Okay, my question on the tank setting. Let me click here. My question is here. I know this is the elevation where it comes from, but the minimum elevation, where did you get and how? Me, I don't know. I just pick a number and put there, but I want to know.
Oh.
Have you catch me? My question, eh?
Yes, I catched you.
Okay.
You allow if I ask someone here to explain you to see if they already catch that one also?
Okay.
Who is ready? Okay, let me help you. Yes. Just the base elevation when the tank is a ground tank, we take it like a base elevation. Yes.
Yes.
And the minimum one is just the ground elevation, but plus that's minimum settlement levels that can happen in the tank. Yes. And then after the initial elevation, is that elevation where the outlet is. You see, the outlet is somehow up at a certain level.
Okay.
And then the maximum elevation is the maximum elevation where water can leach. That is that the overflow. Yes.
Oh, thank you.
So I'm sharing with you the assignment that they are doing.
Okay.
You are supposed to submit it before noon. No, before night. Before midnight.
Before midnight, okay. Share with me.
I'm sharing to you.
Okay.
Those are free Excel. You are getting me?
Yes, I'm getting you. You can share with me.
So those are free Excel. One for the junction. Another one for reservoir.
Sawa.
Another one for tanks.
Okay.
So you are supposed to design that network.
Okay.
At each end node that you will find, you put a demand of 0.9.
0.9.
Yes.
Each node. Sawa.
Then be ready, because there is something that I want to show your colleagues here.
Okay.
And you will need it in your designs.
Sawa.
Okay.
So there are those two lines that share the same.
There's a valve chamber there.
So
hii kitu inapaswa kuicreate sehemu kwanza kidogo. Sasa tutamaliza
So I'm telling these guys, it's going quickly, and I'm glad that they have at least for that one. Please do also your certificate is ready.
What is remaining is only the names. Are ready. What is remaining is only nouns.
Now,
Yes. Names. What is remaining is put names on it.
and this is the exam.
this is the most
No, this is easy. Easy. You know, this is a 10 kilometers only.
the way it is arranged, make complicated.
No.
Yeah, we have intermediate tense.
And in your network doesn't have intermediate things.
Eh?
Your network
Yeah.
doesn't have intermediate things. I have to work on my computer for the
So that's
ready
what
to see.
yeah, that's the second part.
I'm sorry. Something easy. Yes, please. Yeah. Just if you're coming.
Unajua sasa sisi tunao tukachora kwenda kuproject ngome
Hey, you get how many nodes?
8 months.
8 nodes. 8.
18.
8 head nodes. I'm not sure if they are only 8. There are 12. There is one that there is like 3 that you didn't check. See, maybe you put them in the network, but it's okay. Hello, let's see here.
ni chini.
Yes, you have to.
Ndio hiyo.
So, the network is this one here, right? Yes? So then, I just want you to put, I'm just asking you to put 0.9 on each end node. Yes? The demand, yes, at each end node. So then, there are some ways going. Click on this one, 0.9. So, and going this way also is clicking on the other one. Yes, going this way also, click on the other one. Yes, but this is stressful. Yes, there is a way of getting all together. You just come on trace. Trace, yes. We saw that tools. So in trace, there is not only trace. You can find also how to find some nodes. You may need like orphan nodes. Yes?
Yeah.
Orphan nodes.
Often.
Yes, those are nodes that are not attached anyway. Most of the time you start running your model and they are telling you this node is not attached on the network. Yes, when validating. Yes, so there is a way to find it. You just double click on this one, and in your network they will tell you if there is some. For example, let me just have this one there. Yes, this one there, this one there. You see that I put those nodes like this. You see, it's very difficult for me to find them when I'm doing. But by clicking here, you see, they immediately comes. Yes, maybe you were sketching. Unfortunately, fortunately you are all good in drawing. Maybe you may start drawing and then you jump. Instead of continue here, you continue here, and you may not know that it's happened. Yes. By validating, they will tell you that there is a problem. Node is not connected. And you will start asking yourself, where is that node? Where is that node? In a network like this one, it's too many. Yes? Yes? You go there on press, you do offer a node. They will immediately tell you that node which is not attached to the network. Yes? So those are tools that you have to continue exploring. Okay? Then what I was able to tell you is that you have also a way of getting OR and node. Yes? By clicking here, they give you all nodes. Or end nodes. Yes? But you see they are putting also reservoirs. But you can also find a dead end junctions. Only the junctions which are here. Yes? You see it easy.
They do not.
Dead end junctions. Yes? So then from there you can just select, you can do a selection set. Then do a selection set, maybe you call it dead end junctions. Yes, you do okay. Yes, and then as I'm telling you to put all the demand to be 5, and just open attribute table of those demand. Start putting them if you want. Okay. I will show you later.
Can you do that?
Or group edit.
No, group edit not working on yellow. Yes, yellow things. And there is a way of doing that. There is another demand control center. Yes, you open here. It's okay. And from here you can from here you can choose wait. Okay, this one.
Wait.
Yeah, I'm just finding those one. So let me delete this all. Yes, come just here from this one and initiate my demand. All my demand will come here. Yes, all my nodes will come here. Yes, and then I can choose from them the dead one. You see they are coming. Okay, and from here I can just global edit. But this is when all are the same. It will be difficult for you to get many nodes of the same demand. Yes? Is it possible? Yes. Each demand will be different from this one. This village will be different from that village will be different. This water point different from this water point. Wherever the case, you will need to tap the demand. Okay? To initiate them all, I do this. All element. You see, there are some who had that one. Then I do cross, and run my net one. You get also that. So then, after putting that way, there is a valve that I want to show you, which is called a flow control valve. Yes? A flow control valve will help you to do this way. Maybe you are seeing one tank is giving water to another tank. For example, there is a tank here, and just down here, even you are seeing this tank is giving water this way, it is giving water this way. You know why? Because most of the water are going down to a certain other tank in big quantities. Where is it?
You can change the size of the tank.
Can do it like this. So one is here, yes. Another one is here, yes. Another one is here. To mean, most of the water is running down here, yes. And they are going without any control. We are together. So what you have to do is to put a flow control valve on this tank. Yes. I just want you to follow on this. You have to put a flow control valve on this tank. How to do that? You first see the downstream of that tank, how much water it needs. Yes? So for example here, there is a tank here. Water is going in this way, water is going in this way, but here also they are coming some waters, yes? So then, by sizing, I have to know how much the quantity which is coming from this, which is going from this way. We have 0.05. This is at a precision of 3 at least. We have 0.9, yes, going this way, and another 0.9 going this way, yes. Together it's 1.8. Yes, going in these directions. Yes, what I have to do now is to set the water here. How is it? You see here we are having 63. Negative is because the direction. Yes, remember the direction. Yes, you can reverse it. Yes, the flow cannot be negative. So here there is going 63. So I have to set that the goes 1.8. Yes, so I have to set a flow control valve then. So flow control valve is this one. This one.
PSV.
Yes, PSV. So I take it, I put it just near the tank. Yes? It goes to the direction of the pipes. Now it is going like this one. Why it should be going like this one? I will have to reverse it. Yes? It goes this way. Yes? And then I have to set the flow, which I have to pass through that flow control valve. Are good? It's here. Here. Flow setting. Yes? I set 1.8. We are together. I do okay. By learning I have to validate first. It's okay. And then learn. So then in my pipe, these pipes, you will see that now the flow is 1.8, which is needed down here. Yes? What? Which is needed down here. Yes. To mean in this pipe 0.9, in this pipe 0.9, and then we have 1.8. Yes, inlet. So then you get, I think. So then we go to the next tank. Yes? Please. You start from downstream. Yes? You start from downstream, going up to the last one. Yes? But I said each tank must have a flow control valve. It's a must. Each tank must have flow control valve. In design, yes. No, use that one in the model is even taken like a gate valve because it will help you to size the pipes, which is exactly accommodate the flow that you are giving. Yes. Don't think you will see it and in there is even, it's like a valve. It's like a valve, yes. So then we go up. Guys, I'm doing like two tanks. Others will continue doing it.
Because the demand there is somehow much. There is a storage tank. So I want to know that the flow is passing directly to the demand area, because
Yes,
it's necessary that the amount of water that is entering the tank, it should be the same the amount of going out.
by there yesterday we will see. The problem is that we have a small time. If we should go through all of those things, we can even pass like a month doing this. There is a way of sizing even the tank. Yes? By sizing the tank, you will immediately see the water which is going out, size the water which is coming up, and then immediately it will give you the size of the tank. And you will find that way, you will find that the water which is going down is totally different from the water which is coming. And that way, the tank, the time where people will consuming time is extended period simulation, extended simulation. When the people are consuming water, the tank is getting emptying. When people are not consuming, the tank is get filled like this. So you balance all of those situations. But now, as we are still looking on this simulation, we are taking tanks like water passing from there. The water which is entering is the same as the water which is going out. Yes. So then After, you say we already set this. Yes? We come up, let me do a selection set of the tank. So the next one is this one, yes? So this one is easy because you have one pipe which is going down and the other pipe which is coming. We check on the pipe which is interlinked. So we have 4.5, yes? That 4.5 is the one that we are going to put here. While we have there's 4.5, here we have 37. That's where your negative pressure is coming from. Because the water is going like you want and is creating some pressures, yes? Yes, please. So then we put also here a flow control valve, yes? See, my network is reversed also. So I set this one to 4.5, yes? Yes, please. Then I run again my network. So please, before running, you see that at this level, the water was going this way. Yes? That was because the easy way of the water to go was to go down there where there is a big access. But by setting that one, by setting this flow control valve, let's see what will happen. See that water is entering that tank. Yes? Yes, they only went, the others are coming down. Yes? And here also you may find the same scenario. Maybe here there is, we need to 0.8, but here they are passing 1.7. So then here also you put a flow control valve of that part. So all of those negative pressure will start being reduced. At the end, you get the network full designed. Yes? Don't think it was easy like before. Guys.
Hello.
Yes, you was following when we was talking about flow control valve, I think.
Yes, I was following.
You was following.
Yes.
Then start the assignment. I send you the Excel. You start the assignment. Others are far.
Okay. Yeah. Sounds okay.
If you get a challenge, I'm here to help you.
Sawa. It's okay.